Fifth graders, today's lesson is 3.7, Estimating Decimal Sums and Differences. Alright, so just a quick review before we begin. When we are estimating, we are rounding numbers, okay? So we're going to be determining, does the value, is it closer to the number below it, or is it closer to the number above it? So remember, when we do that, using our digits 0 through 9, if it is 0, 1, 2, 3, or 4, you are going to round down. And when we round down, the number actually ends up staying the same. We'll look closer at this in just a second. And if it's 5, 6, 7, 8, or 9, you are going to round up, and the number goes up by 1. Okay, so we'll look more into this in just a minute. Quick review as well, sum, because we're dealing with sums and differences. The sum is the answer to addition problems, and the difference is answer to subtraction problems. Okay, so you may want to be jotting these down in your journal as notes for this lesson. So if we take a look at page 131 in our math books, we see the problem. A singer is recording a CD. The length of 3 songs is 3.4 minutes, 2.78 minutes, and 4.19 minutes. About how much recording time will be on the CD. So that word about is telling me that I am estimating. I'm not going to give an actual answer. I'm going to give an estimated answer. Okay. So we see next to the keyhole it says use rounding to estimate. So that's just confirming that we are estimating. And in this case, they want us to round. Okay, so we are rounding to the nearest whole number because it asks how much time, about how much time would be on the CD. Okay, well we have, see, the first song is 3.4 minutes. The second song is 2.78 minutes. And the third song is 4.19. Okay. Now they want to know about, so I'm going to be rounding to the nearest whole number. So that means I am looking to the number that is in the ones place. So just like we've done before, I believe it was lesson 3.4 where we estimated decimals, we're doing that same work here. So we're going to look to the right. It is a 4. 4 says that I round down. When I do that, it says the number stays the same. Because remember, if we take a look at 3.4, we're determining, is this number closer to 3 or is this number closer to 4? Okay, it is closer to 3. So that's what I mean by the number stays the same. Okay, if it was closer to 4, it would go up 1. 3 would go to 4. Okay, so 3.4 estimated, or rounded, I'm sorry, is 3. 2.78. Again, we're looking at our whole number. We're going to look 1 to the right. It's a 7. 7 falls on the top end of this scale, so we are going to round this number up. 2.78 is closer to 3 than it is to 2. Let's take a look at our last number. 4 is in our ones place. We're going to look to the right. We have the number 1. 1 falls on the bottom end of this scale. So 4.19 gets rounded to 4 because 4.19 is closer to 4 than it is to 5. Okay, and then I'm going to just add these together to get my estimated value. 3 plus 3 is 6. 6 plus 4 is 10. So there are about 10 minutes on that CD. Okay? Now, that's one way you can do this, by rounding to get your estimated answer. Okay, so if you are recording this as notes, which I highly suggest, This was rounding to estimate, okay? And this example was the example from page 131, okay? Now for the next one, because it was using a number line, I just printed the sheet right out of the book because it was easier this way. So for this one, it's important we read this up here because they're going to be talking about benchmarks. So you need to make sure you know what a benchmark is. Benchmarks are familiar numbers used as points of reference because remember, we are estimating. Okay? You can use the benchmarks 0, 0.25, 0.5, 0.75, and 1 to estimate decimal sums and differences. Okay? And if you take a look at the number line, they have those in black underneath. And those are benchmarks, like they said, they're just familiar numbers just because they're common numbers, okay? They're easy numbers to work with. So for this one, it says use benchmarks to estimate 0.18 plus 0.43. Okay, our directions are locate and graph a point on the number line for each decimal. Identify which benchmark each decimal is closer to. Okay, so our first number is 0.18. They've already graphed that one for us. Okay, it would be about here. These are in fives, right? 0.5, 0.10, 0.15, 0.20, 0.25. So 0.18 is between 0.15 and 0.20. So I need to graph my second one, 0.43. Okay. Well, I know that it's greater than 0.25, but it's less than 0.5. So that means it's going to be in here somewhere. These are in five values. So if this is 0.25, this is 0.30, 0.35, 0.40, 0.45, and then we get to 0.50. Now I've got 43, 0.43. So 0.43 is going to be between 0.40 and 0.45. That's going to be about right here. Okay. So this says kind of what we just did in our heads. Think 0.18 is between 0 and 0.25, right? It's more than 0, but it's less than 0.25. And we can look at our picture up here. It's closer to 0.25 than it is to 0.0 or 20. Okay? This again is what we just did in our head. Think 0.43 is between the benchmarks 0.25 and 0.50. All right, it's greater than 0.25, but it's less than 0.50. And then if I look just at this section, 0.43 is closer to 0.5. Okay, so now what they want us to do here is write in what our benchmarks are that we can use to estimate our difference. So instead of using 0.18, we're going to use the estimated benchmark 0.25. And instead of 0.43, we are going to estimate that to the closest benchmark, which is 0.50. Okay. So now, of course, we need to find our sum because we are adding. I like to think of these, if it helps you guys, in terms of money, right? 25 cents is a quarter, 50 cents is 2 quarters, 75 cents is 3 quarters, and $1 is 4 quarters. So if I have 25, plus 0.50 means I have 1 quarter, plus 2 quarters. I have 3 quarters, which is 0.75. Okay, so 0.18 plus 0.43 is about 0.75. Okay, so that's how we would do this one. Let's take a look at the second example. It is the same thing, it's still using benchmarks. You notice on our number line we have 0, 0.25, 0.50, 0.75, and 1. And we are finding the estimated difference of 0.76 minus 0.22. Okay? So I'm going to think 76, it's greater than 75, but it's less than 1. So I know it's going to be between these two. All right, so I can fill this in. 0.76 is between 0.75 and 1. I know it's going to be in here somewhere. Now, this one is set up like the other one, that they are in 5 increments of 5. Okay, so if this is 75, this is 80. Well, 0.76 is less than 80, so I know it's going to be between here somewhere, and it's only 1 more than 0.75, so it's going to be really close. Okay. 0.22 is between 0 and 0.25. Right? It's more than 0, less than 0.25. This confirms that I'm right. So let me graph this. Again, I know they're in 5 increments of 5, so 0.5, 0.10, 0.15, 0.20, 0.25. Well, 0.22 is going to be between 0.20 and 0.25. It'll be almost right in the middle. Okay. So now I need to figure out which one are they closer to. So if I look just at this, 0.76 is closer to 0.75. I'm looking just at this end, 0.22 is closer to 0.25 than it is to 0. Okay, so those are the two benchmarks that I'm going to be working with. So 0.76, I'm going to use the benchmark 0.75. 0.22, I'm going to use the benchmark 0.25. And 0.75 minus 0.25 is 0.50. Okay? So the difference of 0.76 minus 0.22 is about 0.50. Okay, so that's how you're going to be doing your work for today. Remember to be estimating. When you estimate, use your scale. If it's 4 and down, you're rounding down. If it's 5 and up, you are rounding up. Okay.